Okay, so this is the next video. We had just finished 17.4, so we're on the next part. Okay, so variation of Kc with the form of the balanced equation. So your Kc depends on how the balanced equation is written. And so kind of just a flashback to 17.2, we looked at the reaction for PCl5. Okay, and what we have is PCl5 yields PCl3 plus Cl2. We were also able to write a equilibrium expression. Okay, and based on that temperature and those specific concentrations, we were able to calculate its equilibrium constant value. Okay, so let's go on to example 17.5 and look at how the equilibrium constant would change if we were looking at the reverse reaction. So 17.5, calculate the equilibrium constant for the reverse reaction by two methods, i.e., for example, the equilibrium constant for this reaction. So all this is asking for you to do is kind of look at how this number here would change if we were doing the reverse reaction, meaning if this entire expression were flipped. So let's go ahead and write what that reverse reaction is. It would be PCl3 plus Cl2 PCl5, okay? And so method one, okay, well, let's just write the expression for this new state. Now, since this is the reverse reaction, we're going to use this notation here. So basically Kc with a little, looks like an apostrophe, and that just means the reverse reaction. Okay, so PCl5 over PCl3 Cl2. And if we were to plug in all of those values from example 17.2, the concentrations, we would get, okay, let's plug those in, we would get 1.9. Okay, and so we could do that old-fashioned wise and get a new equilibrium constant for the reverse reaction. Method two, however, is pretty simple. We know that Kc, our equilibrium constant for our first forward reaction, is equal to 1 over the equilibrium constant for the reverse reaction. Okay, same thing. We know that the reverse reaction is equal to 1 over our equilibrium expression of the forward reaction. Okay, and so if we know these two relationships, all we have to do is we can plug this straight into here. 1 over 0.53, that was the equilibrium value that we got from the first one, is numerically equal to 1.9. So you have two ways that you can solve this type of question. You would use the first one, maybe if you had the given concentrations. The second method was, let's just say that a problem gave you this value here. Okay, and they say calculate the equilibrium constant for the, sorry, not that value. It would be this value here. Let's say a problem just gave you the equilibrium constant for a reaction that they didn't give you the concentrations themselves. You could just do the inverse of that to get the equilibrium constant of the reverse reaction.